Today's lesson is on factoring special patterns. Let's look. The first one is called the difference of squares. So let's look at x squared minus 16. Let's follow our steps. First step would be to put in descending order. It already is. Second step would be to find the GCF. There's nothing in common between x squared and 16. Third step would be to identify A, B, and C. A, remember we find A in front of the x squared. So I have 1. So A is 1. B, remember I find B in front of x. Since there's no x value, the B value is 0. And C, remember I have 16 and I take the negative with it, or the subtraction. So C is negative 16. Next thing is A times C. And I want to take my table. A times C is negative 16. So I want the factors of negative 16. 1 is 16. Negative 1, 16, 1, negative 16, 2 and 8, that would be negative 2, positive 8, 2 negative, 2 and negative 8, I have 3, 3 doesn't work, 4 and negative 4. So now I add up my factors, positive 15, negative 15, 6, negative 6, and 0. Which one do I want? B is 0. Now I'm going to take and break the middle term up into two terms. Well, I don't have a middle term here. So x squared, my middle term is going to be 4x and negative 4x. Subtract 16. Now I factor by grouping, so I'm going to do my factor trees and my prime factorization. Notice there's nothing in common with all four, so I split it in half. X, 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 2 times 2 is 4. I have a plus sign here, so plus. I do the bottom. 2 times 2 is 4. Got the negative, so subtract 4. X is left. 2 times 2 is 4, that's left. Since this is negative, remember I have to switch the sign from minus to plus. Now I'm going to put it back together. Notice the insides match. X plus 4. And the outside, x minus 4. So I have x plus 4, x minus 4. Now I want to check my answer. Problem in Y1, answer in Y2. Okay, while we're going through the lesson today, see if you can figure out a pattern maybe to go from our problem to our answer. All right, let's look at the second problem now. We have 81x squared, subtract 4. First thing I need to do, put it in descending order. Is it in descending order? Yes, it is. Next thing is, on the GCF, there's nothing in common with 81x squared and 4. Identify A, B, C. A, 81. B, 0, since there's no x term. And C is negative 4. So we want to A times C. A times C is negative 324. First thing we do is 1, negative 324. So that's 323. Now we do 2. 2 and 162. And negative 160. Next one we want to try is 3. Does 3 work? Yes, it does. 3 and 108. Negative 105, positive 105. We're looking for what value? B of 0, so we're a ways away. So next we do 324 divided by 4. That works. 4 and 81. Now we're at 77, so we're getting closer. Now we do 5. 5 doesn't work. We're going to do 6 next. 6 and 54. Now we're at 48. Slowly but surely, we're getting to our number that we want. Now we're going to try 7. 7 doesn't work. I'm going to try 8 next. 8 doesn't work. 9's next. 9 and 36. We have 27. Negative 27 and positive 27. Now we're going to try 10. 10 doesn't work. 11's next. 11 doesn't work. 12. 12 and 27. Getting closer to 0 every time. Next we have 13. 13 doesn't work. We go to 14. 14 doesn't work. 15. 15 doesn't work. Now we try 16. 16 doesn't work. 17 doesn't work. Then we have 18. And 18 works. We have 0. That's the one I want. So our next step is to split the middle term into 2 terms. Plus 18x minus 18x. And the last term stays the same. Now I want to factor by grouping. So I'm going to make my factor trees and my prime factorization. $81, 3, 3, 3, 3, x, x, 18, and 2, 3, 3, 18 is 2, 3, 3 again, and 4 is 2 and 2. Nothing the same in all 4 rows, so we're going to split it in half. We have 3 times 3, which is 9. 3 times 3 is 9 left. Oops, we had an x. So I should have 9x. We have 3 times 3 times x, that's 9x plus 2. Now we do the bottom. I have 2. A negative 2. 3 times 3 times x is 9x. Remember, since this was minus, we switched this out here. So we went from a minus to a plus, and we have 2. Do my insides match? Yes, they do. So inside 9x plus 2, outside 9x minus 2. Now we need to check. Let's put our problem into Y1. my answer into Y2 and see if they match. Are we seeing a pattern? Yes. Yet. Alright, let's look at our third problem. Third problem looks a little bit differently because it has two variables. So to start with, let's act like the y squared is not there. So I'm just going to factor 4x squared minus 36. Note it's already in descending order. Is there a GCF? I do have a GCF in this problem. I have a GCF of 4. So I'm going to take the 4 out. I have x squared minus 9y squared. Now I'm just going to focus on the inside, what's inside the parentheses, x squared minus 9y squared. So I would like to identify A, B, and C. A is 1, B is 0, and C, don't worry about the y squared, just negative 9. Now I need to make a table. A times C is 1 times negative 9, so I got negative 9. So it should be a whole lot shorter than the last one since my number's a whole lot smaller. 2 doesn't work. 3 works. And now I'm going to add them. I got 0. So now I need to split up my middle term. X squared plus 3x minus 3x. And I have subtract 9y squared. Since this has an x and a y in it, my two middle terms should have an x and a y. Now I'm going to factor by grouping, so I'm going to come down and I'm going to make my prime factorizations. X squared, 3xy, 3xy, and 9y squared, 3 times 3 times y. Nothing's the same in all four, so I'm going to break it down. I have x. The x should have gone outside. What's left? X on the inside. We're going to bring the plus down. 3y's left. Now we'll go to the bottom. We have 3 and a y. Since this is minus, I have a minus. Remember, since this is a minus, I'm going to change that last one from minus to a plus. What's left? X and 3y. Do the insides match? Yes, they do. So x plus 3y. And then the outside, x minus 3y. And next we're going to check. Put our problem in y1 and our answer in y2. We can't put the y's into y, so we're just going to act like the y doesn't exist, or we could store and use the home screen. Are we seeing a pattern yet? Hopefully we are. Okay, next we're going to move on to difference of perfect cubes. So let's first start off by distributing this problem. I have x squared plus 2x plus 4. Then we have negative 2 times x squared plus 2x plus 4. X times x squared is x cubed. X times 2x plus 2x squared. X times 4 is plus 4x. Negative 2 times x squared, negative 2x squared. Negative 2 times 2x, negative 4x. And negative 2 times positive 4 is negative 8. Now I'm going to combine my like terms. X cubed I have plus 2x squared minus 2x squared, so they cancel out. Plus 4x, positive 4x, minus 4x, they cancel out. I'm just left with x cubed minus 8. Now, let's look at the answer we got. Can we check it? Y1 is my problem, Y2 is my answer. Well, let's look at the problem over here to the right. Oh, that's just my answer. Do we think there's a pattern? Well, maybe. So, if I'm going back up, what did I do in difference of squares? Did you take the square root? Well, let's take the cube root of x cubed. Well, the cube root of x cubed is x. What's the cube root of 8? 2. Do we see here? X, 2. So x and 2. So the cube root of both. Now, over here, I had a minus, minus. So we're going to put, operation stays the same. Next thing, x squared. How do we get x squared? Well, we just took the first term and squared it. So x squared. Let's look at the middle term of the trinomial, 2x. I took the cube and the cube here, and I just multiplied them together, 2x. What happened here? I went from minus to a plus, so it switched. And then how did I get 4? Well, I took 2 and squared it. And that last term is always plus. Can I check it? Y1, Y2. Let's look at another one. Let's start by distributing it out. 2x times 4x squared plus 6x plus 9. Subtract 3 times 4x squared plus 6x plus 9. We have 8x cubed plus 12x squared plus 18x minus 12x squared minus 18x minus 27. Combine like terms, 8x cubed plus 12x squared and the minus 12x squared cancel out. The plus 18v and the minus 18x cancel out. Subtract 27. Notice that my problem here on the right. What do you think we need to do first? Well, let's take the cube root of 8x cubed. The cube root of 8 is 2. Cube root of x cubed is x. 27. Cube root of 27 is 3. Let's take the first one, 2x. We're going to keep this operation the same, so 2x minus 3. The next thing I do is take the first term in the binomial and square it. 2 squared is 4, x squared is x squared. Now I'm going to take the two terms and multiply them together. 2x times 3, 6x. Kept the sign the same. Now I need to switch the sign. And then the last term is going to be taking the second term in the binomial and squaring it. And then the operation is always positive in the second. Okay, let's look at sum of perfect cubes. If the difference of perfect cubes had a pattern, do we think that the sum of cubes will have a similar pattern? Well, let's see. If we take the cube root of 8, what do we get? 2. Cube root of x cubed is x. Cube root of 64 is 4. So I'm going to take the first term, second term. I'm going to remember I kept the minus in the difference of two cubes. So now I'm going to keep the plus for the sum of two cubes. In the difference of two cubes, we took the first term and squared it. We're going to do the same thing in the sum of two cubes. So 2 squared is 4, x squared is x squared. In the in the difference of two cubes, we took and multiplied the two terms. So in the sum, we're going to do the same. 2x times 4 is 8x. And in the last one, we switched the operation. We're going to switch the operation again. So we went from plus to minus. We said that it will always be positive in this last one. And we take the second term and square it. So 4 squared is 16. Now we need to check. Problem in y1, answer in y2. Let's look at one more. First thing we need to do is take the cube root of 216. Cube root of 216 is 6. Cube root of x cubed is x. Now we take the cube root of 8, 2. And we'll keep the sign the same, plus. Now we take and square 6x, get 36x squared. Multiply the two together, we get 12x. And square 2, we get 4. Switch the sign, keep the same. Now, do we notice anything here? Let's look at 6x plus 2. Does it have a GCF? Yes, it does. Look at 36x squared minus 12x plus 4. Does it have a GCF? Yes, it does. So, would it have been easier to take the GCF out at the very beginning? I believe so. So, let's take the GCF out at the very beginning. Remember, we always should look for the GCF first, and if we do, we can save ourselves really big numbers. So I'm going to treat 216. That's 2 and 108. 108 is 2 and 54. 2 and 27. 3 and 9, and 3 and 3. Treat 8, that's 2, 2 and 2. So I need to make my product factorization. 2, 2, 2. 3, 3, 3. And 8 is 2, 2, 2. What's the same? Now 2, 2, and a 2. So 2 times 2 times 2 is 8. So let's take the 8 out. What's left? 3 times 3 times 3 is 27. Let's don't forget our x cubed. Plus, what's left in the second line? Nothing. So what does that mean we have? We have a 1. Now, let's just focus on the binomial that's inside the parentheses. We're going to take the cube root of 27. I believe that's 3. Cube root of x cubed is x. So we have 3x. Cube root of 1 is 1. Keep the sign the same. Now we're going to take and square 3x, so we get 9x squared. Multiply the two together, we get 3x. And square 1, and we get 1. Now, I was supposed to switch the sign on the second one. So we need to switch the sign. So that should be subtract 3x. Now, let's check it. Problem in y1, answer in y2. Does it match? No, it doesn't. Why is that? Well, remember we had this 8 here. That was the GCF. Did we bring it down? No, we didn't. So we need to bring it down. Now let's check. Y1 is the problem and Y2 is the answer. And does it work? Yes. Looks like it was a lot easier once we took out the GCF first. The numbers were much easier. Okay. You try these. Try these also. And let's look at the closure. What is the pattern for factoring a difference of cubes? Where is the negative symbol? What is the pattern for factoring a sum of cubes? Where's the negative symbol? And explain how you would factor the following. 27x to the 6th y cubed plus 64.